Hi everyone, I'm Sehi Lee from Seoul National University. In this presentation, I'm going to talk about CloakingNote, a novel desktop interface for server writing using Decoy text. I will start with some of the problems we all face in our workplaces these days. People often have to take care of their personal things at work. For example, you may receive emails or messages from your friends and family that need your immediate responses, whether it's for dinner appointment or parties. However, you are often reluctant to do so because nearby colleagues might stare at your screen and notice that you are doing personal things at work. Or maybe your boss appears unexpectedly and he's not going to be happy with what you're doing at the moment. Also, we have to protect our privacy. In crowded places, displays on your personal devices can be seen by anyone around you. As a result, people risk exposing their private information. These issues are dealt in two research fields. First, some people design server input interfaces to elevate the social issues. However, such interfaces use gesture inputs so that the writing performance is quite limited. Other people designed the shoulder surfing resistant input interfaces to elevate the privacy issues in crowded places. However, they mainly focused on short inputs like passwords or PIN numbers rather than longer inputs like messages or emails. To address these issues and satisfy both the subtlety and reasonable writing performances, we designed CloakingNote. The main idea of CloakingNote is taken from a common practice in magic called misdirection. Misdirection is a principle used to draw the audience's attention away from a magician's trick, just like I tricked you from the previous slide. So this is the previous slide that you just saw 20 seconds ago. Did anyone notice my personal text on the corner? Few of you might have noticed, but it is hard to notice the personal text because of a decoy text, an attracting text in the middle. In CloakingNote, we use this prominent decoy text to hide the real text from being seen by others. So this is an example of using CloakingNote. On the right, the text is being written in a word processor. As you guessed already, this is not actually being written by the user. The actual text by the user is being written on the left. In next few slides, I will show the design and implementation of our system. First, we designed the interface of a CloakingNote to make it look like normal application to even disguise the status phase of CloakingNote. These kinds of design decisions are based on our 4 design guidelines introduced by Anderson et al. In this presentation, we show how CloakingNote reflects the last 2 guidelines. Since the repeated use of the same trick might eventually lead observers to notice the secret action, a server interface should allow users to alter appearance of the secret interaction. In addition, server interface should enable users to customize it to reflect the user's different context. To fulfill these 2 guidelines, CloakingNote supports various configurations for the real and decoy text. The prototype of CloakingNote consists of 2 windows, one for the real text and another for the decoy text. By using the windows, users can change font, size, and color of the real and decoy text. So, how do we configure CloakingNote? I explain configuration of CloakingNote based on the decoy text. First of all, users have to decide which writing interfaces they pretend to use. In this example, users are trained to pretend to write the decoy text on Evernote. To do so, the users put the window of the decoy text on Evernote. When users start to write, both the rear and decoy windows become transparent, flood above other interfaces, and render letter one by one when users press keyboard. Predetermined letters appear in the decoy text area, while the rear inputs appear on the rear text area. So I'm going to show two of the many configuration examples which are created by study participants. This is an example that I previously showed you. A participant was a graduate student. She said that she pretended to be in her laboratory and tried to deceive her advisor by pretending to work on her research paper. To do so, she used her draft as a decoy text so that whenever she types a keyboard, the letter in the draft can appear one by one. She then used the font of Times New Romans to match the decoy text well with her draft in the MS Word. Then she placed Google search wizard to pretend to find references on the left. And actual text was on the left corner. In another example, the participant was an undergraduate student. He tried to pretend to write a school report using an online submission system and watch a related lecture video at the same time. He then wrote the real text on the left. After designing CloakingNote, we conducted a subtlety test. In the subtlety test, we vary the contrast of the real text because human visual search performance is highly related to the object background contrast ratio. In the study, on actor, one of the authors used CloakingNote while each participant observed the screen. We varied the contrast of the real text between participants, and 3 contrast levels were selected from the previous studies. The screen layout was fixed across all conditions for all participants. On the right, we overlaid a decoy text inside MS Word. On the left, we show a web page whose content was related to that of the decoy text. The real text was overlaid inside of the web page. In each session, participants were asked to enter a room and stand behind the actor's right shoulder. Participants did not have any previous knowledge of what the actor was really doing. We told them that the experiment was about how interruption affects text performance, and they were the ones who interrupt the other person. Then they have to carry out 2 tasks. First, they had to ask the actor a question. The questions were given to participants one at a time before they entered the room. And they were related to the content of the decoy text. Second, they have to observe what the actor was doing. These 2 tasks reflect the real-world scenarios in which one person approaches the other working at a computer and engages in a conversation. After 30 seconds, we knocked on the door to signal participants to leave the room and report the answer to the question as well as their observations. We repeated the session until the participant either noticed what the actor was really doing or finished all 9 sessions. According to results, only half of the participants noticed the use of CloakingNote. Only 5 participants noticed the content of the real text. Our results suggest that CloakingNote did a good job in hiding content of the screen writing, secret writing, as well as the use of the system itself. Especially, the use of the system was subtle for all participants when the actor used low contrast real text. At the end of the study, we asked our 18 finders how they were able to recognize the use of CloakingNote. Before the study, we thought of some clues. For example, press key and input decoy letter are different in CloakingNote. So finding this difference might lead observers to become suspicious. Moreover, the decoy text can unnaturally stop in the middle of a word. However, no finders reported such clues. One finder said that after I found the real text, I tried to confirm which text is being written by the writer by comparing between the letter appear on the screen and keyboard press. However, it was impossible because I couldn't observe both at once. In contrast, almost all finders responded that just the real text being rendered in an unexpected place on the screen attracted their attention. This demonstrates that visual subtlety of the real text is much more important than resolving the incomplete disguise of the decoy text. After the subtlety test, we conducted a performance test to see how the contrast affects the writing performance. This study consisted of 2 sessions, quantitative and qualitative evaluations. Participants used CloakingNote in both sessions, while an actor showed the self-tone in the second session to let the participant experience the privacy issues with CloakingNote. In the second session, we assessed the typing performance. In the first session, we assessed the typing performance in terms of speed and accuracy, and we used the within subject factor of configure using 3 contrast ratios from the first experiment. In addition, the highest level of contrast with a bigger font size was used as a baseline condition. The baseline condition also let users enter text in MS Word, which reflects a situation where the participant would write the text without CloakingNote. The low, mid, and high contrast real text was written on the left, while the baseline real text was written on MS Word. Each phrase was shown on top of the typing area until the participant pressed the Enter key to finish and see the next one. In the next session, we let the participant freely write a short essay for 5 minutes, while an actor picked over their shoulder 3 times. To provide a realistic experience of shoulder surfing, we told each participant that another participant will try to find out what you are doing. The participant freely changed the layout of on-screen components up to 10 minutes before writing. According to the research, there was a statistical difference on contrast in terms of typing speed, but all of the contrasts showed a fair performance compared to that of using gesture inputs. During the quantitative evaluation, we investigated some of the users' interesting layout strategies for hiding the real text. First one is foreground match strategy. 6 participants placed the real text in a contextually meaningful position so that it seems like it initially belonged to the context. Next one is background match strategy. 6 participants laid the real text in places where the presence of text is not normally expected. Then they customize the real text so that it has a protective appearance. In this case, the real text is hidden behind the taskbar on the bottom. Last one is distractive strategy. 5 participants put various components on the screen to distract an observer's attention away from the real text. 2 participants even turned on the sound while they played the video. One of the participants very satisfied with the result, saying that, "I suppose that the observer wouldn't ever notice my real text." By using the idea of users' layout strategies, we could imagine extending CloakingNote to other types of interaction. First of all, we can imagine a subtle video watching interaction using foreground match strategy. For example, an online video lecture can be played in the center of the screen, while a movie is disguised as a video advertisement on the side. Some of the Android smartphones support a biometric authentication called Face Unlock. According to a survey result, people didn't want to use Face Unlock because it is embarrassing to show their faces through a screen to others every time they authenticate their devices. To address the problem, we can apply the background match strategy. For example, users can pretend not to take a selfie by showing a prominent web page, while deemed user's face is shown in the corner. So, in summary, we presented CloakingNote, a novel desktop interface for subtle writing using Decoy text. We conducted 2 user studies, and their results show that CloakingNote was effective in hiding their real text and could be used with reasonable writing performance. Finally, we characterized the users' layout strategies and introduced the idea of extending CloakingNote to other types of interactions. Thank you for listening. I will be happy to take any questions.
Questions?
Hi, I'm Kentaro Go from University of Yamanashi. Thanks for the great talk.
Thank you.
My question is, user sometimes types in delete key. So what it happens for the decoy text?
What do you mean about jacked writing?
Delete key. So remove.
Delete key.
Yes.
So we designed CloakingNote to when user write key using a CloakingNote or other key doesn't work. So real input are placed in the real text while the decoy text show the predetermined letter, but we use the backspace key differently, because when user type a keyboard, the backspace key is little far from the middle of the keyboard, so that when user press delete key, the observer might see something wrong, because when we input the delete key and a letter deleted from the real text while the predetermined letter input in the decoy text, the observer will become suspicious. So we differently use the delete key. Yeah, but I think that the other key acted same as others, and the participant from the first study said that they were not able to see both the keyboard and the screen, so that it doesn't really reduce the subtlety of CloakingNote in our study.
Any other questions for Sehi?
Thank you very much for the talk.
Thank you.
I was curious about how you might apply this to interfaces that use text but also require other input mechanisms, such as mouse input or buttons. Do you have any insight into that?
Actually, we didn't really consider about the mouse interaction, and because we focused on short inputs like text messages or email or maybe short diary, that doesn't need many interaction with the mouse. But we think that when we consider much longer inputs like work-related documents, we also need to consider the mouse input. And maybe we think that using some of the user's layer strategy, we can make the mouse interaction shorter, I guess. But I think that it is interesting future work.
I'm Taekyung Kwon from Yonsei University. I'm wondering if you have considered an adversary who uses a camera, and if you have any opinion against such an adversary.
Can you speak the question again? Adversary?
Attacker who uses a camera.
Camera.
Yes.
So actually, in this study, we concentrated on the attack of casual server surfing. So we didn't actually thought about the video recording attack, that such the sort of recording. So I think that when observer use such the sort of attack, it will be really hard to make the real text order. But it could be also considered as a future work. Thank you.
Right. Let's give Sehi Lee a big hand. Sorry. So our next speaker is going to be Leah Veru from MIT, and she'll be talking about Mavo.